Hello, Bethany and Finley. Hope you're having a good day. I am hanging out in the camper because the kids are inside making a mess and fighting, and I needed to get some space. So we pulled our camper into our driveway. So this is kind of my quiet space. Um, anyway, I hope you enjoyed the last lesson. Today's lesson, we're going to learn what exactly is gravity. And this is when I said you need a couple of empty plastic bottles or something like that. I'll tell you why you need those later. But let's figure out first what exactly is gravity. And you can see this poor cat. He's like, turn the gravity back on. Quick, help. I think that's supposed to say. Um, yeah, this poor cat is stuck somewhere with no gravity. And as you probably know, gravity is a pretty useful thing. So gravity helps keep us on the ground because we are being pulled towards the center of the Earth. Now, obviously, when we kind of hit the edge of the Earth, we stop. And this is actually another lesson, but the Earth is then pushing back on us. So it's keeping us up, but it's also kind of keeping us from floating away. Also, you may know this too. Gravity is what actually holds the planets in orbit around the sun. The sun is this big, massive ball of kind of burning gas and plasma, and it's as we on the Earth, kind of the Earth is going, but it's held in this kind of circular orbit around the sun because the sun is pulling the Earth in and the other planets with gravity. So gravity is a force. Before we said forces are anything that pushes and pulls. Well, gravity is a special one. It only pulls, just pulls. And like I said, it's a very useful thing. Otherwise, we would all be floating off into space, or our Earth would just be zooming around the universe, and we'd eventually lose our sun and maybe find another one. I don't know. Okay, here we go. So there's this little thing I'm just going to talk about called universal gravitation, and I'll talk about why it's important. So two key things about gravity. Gravity acts everywhere in the universe, not just on Earth. So obviously we know that it pulls us down, but like we said, it also does kind of happen everywhere in the universe. That's what causes us to orbit the sun. Also, lots of people think that when they go on the moon, you're weightless. Well, you're not, because the moon does have a little bit of gravity as well, just not as much as the Earth. So when you see people jump on the moon, they kind of jump up, but they do come back down eventually. Same is true if you went out to the edge of our universe into other universes. There's going to be gravity everywhere. The other thing, sorry, I should talk about this. This is me skydiving about 15, 16 years ago. And you can see I did what's called a tandem skydive. So this is me down here looking very panicked. And this is the guy that I was attached to. He looks a lot calmer than I do, obviously. He's done this a few times. But yeah, even up in the sky, we are being pulled back down to the center of Earth. Here's the other thing. Any two objects that have mass attract each other. So again, gravity is pulling things together. We always think that we're just being pulled towards Earth. Believe it or not, you are actually pulling Earth up towards you a little bit as well. But because Earth is so big, we notice that a lot more. It has a big pull. So here, the sun has mass, and the Earth has mass. And when we say it has mass, we just mean it has lots of stuff inside of it. That's called matter. Generally, you think of anything that has weight as having mass. We'll talk about the difference between mass and weight later. All right. So here's a good way to visualize mass. You have a trampoline. If you were to say take a tennis ball and put it on the trampoline would maybe do this just a little bit. It would just dip slightly, but not very much. If you were to take a bowling ball and put it on the trampoline, it would go and dip right down. And that's what this is. Or this is what this is showing. This is a bit of a weird concept, but this is actually like space-time fabric. So it's just, think about it as being the trampoline fabric, the stuff you jump on. And anything that kind of sits in space-time fabric bends it, or kind of dips it down, just like the sun does. And I'm going to imagine this is the sun, because we know that pretty well. The sun's really big. It's really going to push down on the fabric. That means that our Earth is flying around it, but see, it can't really escape. It can't get outside because it's in this dip created by the sun. So the bigger the object, the bigger dip it's going to make. Now this, you can't really see it, but it is making a little dip too. So everything makes a little dip. Everything with mass has gravity. The other thing is, if something is far away, then it has less gravity. So less gravitational pull. So that's why there are other universes out there, and that's why we're not being sucked towards other suns, other stars, because they're so far away. So say this is maybe our star, or our sun, and this is another star, and Earth is just kind of zipping around it. It's pretty happy zipping around here, and it's not going to follow this one, or it's not going to follow this gravitational pull, because it's so far away. And that's why. All right, onto your hands-on thing for today. I had you get 2 like fizzy drinks bottles or something similar. Make sure they're the same. What I want you to do is this. Leave one empty and fill the other one up with water. And then go to somewhere safe, but somewhere high up. You can see Rowan is at the top of my tall ladder. He's sat down, so he's pretty safe up there. I'm thinking, ask your parents if it's okay, but they have the balcony by their bedroom. I don't think there's anything underneath it apart from patio. Maybe I'm wrong. But I think if you could go up there and drop something onto the patio without it obviously damaging anything, you could do this. You're going to take both of them up there. You're going to drop them both at the same time and see which one hits the ground first. So maybe make a prediction. Think, okay, if I've got one full one, it's obviously heavier than the other one. Which one's going to hit the ground first, and why? And then go try it and see which one hit the ground first. What's really cool, I'll show you a video after you've done it. We recorded it in slow motion, and that's really cool to see. So I'm sure your mom or dad have slow motion video on their camera or on their phone. So do that. Send me a video if you can. I kind of want to see it. And I would do it like 3 or 4 times, but make sure you're letting go of both of them at exactly the same time, because this is science and we've got to make sure it is precise. So precisely the same time, drop them. All right, send me a video. I want to see what you guys do, and then we will talk about why that happens. Okay, bye for now.